You are welcome to online tutorials with Fametite the Schoolboy. Today we are going to take a look at physics and we have a question on the board. Actually, this question was sent to me by one of my students to solve. So I felt it is proper to make a short video of the question so as to share it for those that may be in need of it. The question says, a wire is subjected to a tensile stress of 2.5 times 10 to the power 9 Newton per meter squared. Calculate the Young's modulus if the length increases by 5% of its original length. Now, this question has a lot to do with elasticity, Hooke's law specifically, another Hooke's law, a kind of modification that involves Young's modulus. Of course, we know, provided that the elastic limit has not been exceeded, as you apply a force to an elastic material, as you stretch it, the length will do what? Increase. So the force you apply, the force per unit area of the material you apply is directly proportional to the what? The change in the length. Am I communicating? The change in the what? The length. Now, or the extension as the case may be. Now, this force per unit area, which is a form of pressure on this material, causes distortion on the nature of the material and probably deformation as time goes on. Now, this stress on it, this force per unit area, is what is called tensile stress. Tensile stress. Now, why the deformation or distortion caused on this material is called what? Strain on the what? Material. Strain. Now, according to Young's model, according to Hooke's law, provided that the elastic limit has not been exceeded, this tensile stress is directly proportional to the tensile strain on the material. So we now have this relationship solution that tensile stress is directly proportional to tensile strain. Now, to remove this sign of proportionality, you need to introduce a constant, and this constant is called Young's modulus. So, tensile stress is equal to Young's modulus dot tensile strain. That implies that Young's modulus is equal to what? Tensile stress over tensile strain. Now, tensile stress, as I said before, is force per unit area, which is F over A. While tensile strain is the ratio of the extension caused by this stress over the original length of that material. So let the extension be E and the original length of the material be L. So tensile strain is E over what? L. Now, this is the relationship between Young's modulus, tensile stress, and tensile strain. If you look at this extension over length, this ratio has no units because this and this have the same units, so these have no units. So actually, your modulus has a unit which is Newton per meter squared, which is the same unit as what? Tensile stress. Okay, now let's go back to the question. The question says that a wire is subjected to a tensile stress of 2.5 times 10 to the power 9 Newton per meter squared, which is this. Okay, calculate the Young's modulus if the length increases by 5% of its original length. So what it means is that extension is 5% of this. So 5% of L is certain as saying 5 over 100 times L, which is 0.05 L. So E is actually 0.05 L. So now we put everything back. Let me write it out here. Stress is already here. E is 5 over 100 times what? L, which is 0.05 what? L. While L is still what? L. L is still what? L. So if that is the case, that means E over L is equal to what? 0.05 L over what? L. L will cancel L. So we are left with what? 0.05. So this E over L is what? 0.05. While F over A is 2.5 times 10 to the power 9 Newton per meter squared. So we now substitute everything here. We now have that our Young modulus is now equal to 2.5 times 10 to the power 9 Newton per meter squared all over what? 0.05. Applying law of indices, scientific notation or standard form as the case may be, this is certain as saying 25 by having decimal movements. As this moves here, this will reduce from 9 to 8. We have times 10 to the power 8 Newton per meter squared. All over, changing this to standard form, we have 5 times 10 to the power minus 2. So 5 will cancel 25, we are left with what? 5. For this to divide this, applying law of indices, the certain as saying 3 to the power 8 minus 2. 3 to the power 8 minus 2. So we have something like this, that y is equal to 5 times 3 to the power 8. Law of indices, this will come up minus 2 Newton per meter squared. That implies that y is 5 times 10 to the power 10 Newton per meter squared. This is the Young's modulus. So the answer to the question is 5 times 10 to the power 10 Newton per meter squared. Thank you very much for your attention. Please, if you have any question, feel free to chat me up on WhatsApp. My WhatsApp line is on the screen. You can also subscribe to my YouTube channel. The name is Eternity, the Schoolboy. It's also on the screen. Thank you very much. Please like my video, share, comment, recommend your friends and your students, your colleagues, as the case may be, to watch and share my video. Someone else may be in need of it. God bless you.